So, continuing here in 5.1 on section 5.1, I'm just going to take a look. Suppose that there is $1,000 invested at a compound interest rate of 9%. Find the amount of principal after 1 year if the interest is compounded quarterly, if the interest is compounded monthly, if it's compounded weekly, if it's compounded daily, if it's compounded hourly, if it's compounded every minute. So every single one of these we're going to have the same 9%. Every single one of these we're going to put $1,000 in. Every single one of these we're going to have a 1 in for a year, as in time, 1 year. The only thing that's changing is n every single problem. That's what's changing. Okay, so let's figure out what n is. Quarterly means 4. I think there's 4 quarters in a dollar, so that means 4 monthly. There's 12 months in a year. Weekly, we have 52 weeks a year. Daily, we have 365 days. Hourly, to find hourly, I take that 365, because that's how many days, and I multiply it by 24, so that's how many hours there are in a year. And then minute, in every hour there are 60 minutes, so I multiply that by 60, and that's how many minutes there are in the year. So basically, I'm going to do the problem, but put that in for n. Then I'm going to do the problem, but put that in for n, and so on.
Well, I guess that makes...
So, quarterly, I put a 4 in. And when I put the 4 in there, I end up getting $1,093.08. Monthly, I put a 12 in there. I end up getting $1,093.81. Not a big difference, only some cents right there, if you notice. Then daily, 365 days. Still, in the large scheme, this is 93.81. This is 94.16. So we're only talking like 40-ish cents that it went up. By doing it from monthly to daily. Weekly, put in a 52 there. It actually seemed to go down a little bit, which shouldn't be the case. I think it should be a 19 in there. This is supposed to be, we have weekly, weekly would be less than, that is right. Weekly is less than daily. This would be hourly right here, not weekly. Hourly, notice how it only went up 1 cent. So from daily to hourly, it only went up 1 cent. And from minute, doing it every minute, it didn't even change. The point I'm getting at here is, yeah, calculating it more than once a year is more beneficial. But the higher up you get, you notice that it is gradually getting higher. Quarterly, monthly, weekly, daily, hourly, every minute. So instead of writing in these large numbers, I mean, we could do it every second. But what's the point of making this number even bigger? Because there is another way to do these problems when they get so high, as in the number of times you calculate it. There is a better way to do it than that.
St. Damian's beer.
And that is called continuously compounded, and that's what this E is. The E is an actual number. Okay, so it's not a letter to plug in a value for. That's an actual number. The P stands for the principal, money you put in. R still stands for rate. T still stands for time in years.
Scorpion woman.
The number E is this right here. Whatever number you put in for n, it's going to basically be the same thing every time. That's approximately 2.711828 is approximately what it is.
23 years of broadcasting. I thought I'd seen it all, folks, but
So, if f of x is e to the x, suppose 20,000 is deposited into a money market account that has a rate of 8% per year compounded continuously. The key word here is compounded continuously. When you see the word continuously, that means you're going to use the a equals p e to the rt function. Okay, so you know you're going to do that because you see the word continuously. 20,000 is p, 8% that goes in there, and determine what it is after 5 years. I put a 5 in. So in your calculator, you would type in 20,000 times, your exponent is second and natural log, 0.08 times 5. You end up getting 29,836. Let's see here. $29,836.49. So by compounding continuously for 5 years at that interest rate, you would make about $9,836.49.
Shut up!
Example 10, an investment of 10,000 increased to 28,576.51 in 15 years is compounded continuously. Find the interest rate. So I know what I started with. I know what I put in. I know what it ended with. I also know how many years it took, but I do not know the rate that it went up. So I need to get this E by itself. So in order to get that E and that R by itself, I'm going to divide by the 1,000 here on both sides, and by doing that I end up getting 2.857651 equals ER to the 15. So we've not learned how to do this yet, so right now we're just going to have to guess and check, but there is a way with natural logs that you can solve this problem really quickly and get an answer. So you can just kind of plug in by guessing and checking to see what it is by putting in some percents to see what you end up getting, and it is about 7%. To solve this, if you do the natural log on both sides, the natural log and E are opposites of each other, so they would kind of go away, leaving you with a 15R equals the natural log of 2.857651.
Just thought you'd like to see what a skater's body really looks like.
Laws of growth and decay. That is the initial quantity that you put in. That is still the rate, and that is still the time in years.
I'm Ron Burgundy. You stay classy, San Diego.
The population of a city in 1970 was 153,800. Assuming that the population increases continuously at a rate of 5% per year, predict the population in 2010. Here's the population. It's compounded continuously. That's why I know it's e to the rate is 0.05 t. Find the population in 2010. Well, 1970 to 2010, I need to find the time. So to do that, I just find the difference, which happens to be 40 years. So I plug in a 40 for that time, and when I plug it in, I end up getting about 1,136,437. Okay, these aren't hard problems. It's just about knowing where to plug the values in.
Wow.
Okay, and this is just a graph. Honestly, just plug it in on your graphing calculator. I don't care that you know how to plug the stuff in, or to solve. Just literally just plug it in on your graphing calculator. And this is an example of the table that'll show up on your graphing calculator. The E key is second ln. That's the E key, just so you know where that is by the time it's all said and done. If you have any questions or concerns, please let me know with some emails, I guess. I'll have a good day, yeah?